Let's create two DFAs today. One for the language W, where W is any string in AB clean plus clean star, and a second one, W, where W is any string not in AB clean plus clean star. These languages are complements of each other, meaning they are kind of like the inverse of each other. And once we figure out this first language here, you'll see why it's really easy to then get the complement of that language, aka this second language. So first, let's begin with this first language here, where W is any string in AB clean plus clean star. But first, what do these symbols mean? This might be your first time seeing these symbols, so let me outline them for you. So this is the clean plus. So plus means essentially that we have one or more of the symbol that it hovers over. So in this case, it's B. So we have one or more B's. That's what the clean plus means. And then the clean star means that we have 0 or more over the symbol it hovers over. And we can see that it hovers over this entire equation here. So this means that we have 0 or more of A and then 1 or more B's. So that's what this language translates to. This might be your first time seeing those symbols. So that's a quick explanation. But let's kind of dive into the logic of how this would work. So let's first simplify this by taking the inside of the parentheses. We have AB clean plus. So what languages fit inside this this here? So if we have, say, AB, that fits because we have A, and then we have one or more B's. If we have A, B, 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 that also fits because we have A and then one or more B's. If we have A and then no B's, that does not fit because we need one or more B's after it. If we have just B, B, that doesn't fit because we need an A. Now, if we add this clean star above it, this means that we have 0 or more of those strings that I just wrote over here. So if we have AB, is that correct? Yes, it is, because we have 0 or more of this AB clean plus. We have exactly 1. If we have AB, AB, that's also correct, because we have 2 of this language here in the middle. If we have ABB, that's also valid. If we have ABBA, that's not valid, because you see, we take the language inside here, and we apply it to whenever it is not valid anymore. So that would be ABB. And then we have an A as kind of our second segment. Well, A doesn't fit inside AB clean plus, so that would not be valid. Now, if we have nothing, like an empty input string, is that still valid? Yes, it is, because we need 0 or more of whatever's inside the parentheses, so we can have 0. If we have 0 of these, then that's, technically just an empty string. So that's kind of the logic behind the problem. Now we can start creating the DFA. So we know that we need to start with an A. Starting with an A is necessary. So let's create our first state here, transitioning to a second state. We'll call this state 1 transitioning to state 2. So if we feed in our input string, let's have one on the side here. Let's have A, B, B, A, B, B on the side here. So we feed in our input string. We start with an A. So we hop from state 1 to state 2 on an A. Now what do we want to do on a B? Let's create a transition on B to a state, we'll call this state 3. So once we're at state 3, that means that we know that we have A and then B. So we have an AB. Now, if we have a bunch of B's after it, remember we did A, B, 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 was that still valid? It was. So what that means is we can have as many B's as we want after the A, and it will still be valid. It's only invalid if we have an A after all this, and then there's no B following it. So that means that we can just, on state 3, we can just loop on B, so that it doesn't matter how many B's we have after. So now we've kind of mapped out our ideal scenario here. If we have A, B, B, then we're going to land in this final state here, and it's going to keep repeating. But obviously we can have more complex strings than this, and this is not the end. So let's create our except state here. This is going to be where our string is valid. And let's continue adding more test cases. So say we have A, B, 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 whatever, and then we have another A, B. Well, where do we want to go? So we're essentially here right now, and we have an A input to our diagram starting at state 3. We want to go back to state 2 because we need to make sure there's another AB. We can keep repeating on B all we want, but as soon as we get an A, that means we have to look out for another B. If we get another A and there's no B following it, then that means it is invalid. So we're going to send it back to state 2, which is basically waiting for another B to send it to state 3. So that means we need AB to get back to our except state. So that's what we want. Okay, so what about some other scenarios? What if after this we had AB? Would this be valid in our language? No, it would not, because we have two A's after each other. That's never possible in our language because we need one A and then a B after. So if an A does not contain a B after it, then we want to reject it by default. Now, what does this mean? So we can create a state. We'll call this state 4 down here. This will be our reject state. So when we have two A's in a row, we're going to go to state 4. And we're never going to accept. We're just going to chill here. So we can loop on A comma B on state 4 because this is the dead state. This is the state that we know we're never going to accept if we reach here. Okay. So now let's think, where else in our diagram are we going to have two A's in a row? So we have an A here, and then conveniently this arrow also leads out from state 2 to state 4. And we have an A transition here, and this arrow leads to state 4. So it looks like we've mapped out every situation where we're going to have two A's in a row. This is helpful to know this kind of stuff because it's very useful to know that we're going to reject no matter what if there's two A's in a row, because then we can do stuff like this and ensure our diagram is correct. So let's see, what else do we need? We need a B transition on state 1. On every state in a DFA, we need both an A arrow and a B arrow coming out of it. Well, it depends on the alphabet. So the alphabet is declared here. We have A comma B. So we need an A arrow and a B arrow coming out of every state. So where should our B arrow come on state 1? Let's imagine this as an input string. So this would look like we have B as our very first input and then AB. So if we have B as our very first input, is this going to be a valid string? No, it's not, because we need to start with an A. If we don't start with an A, then our string is invalid. Unless, of course, we have nothing in an empty string, then it's still valid. But if we have characters in our string and we start with a B, well, then that doesn't meet our language requirements. So then we can just send it to the dead zone, and it will be rejected automatically, and we're never going to accept it. Okay, let's check all of our other states to make sure that we have both A arrows and B arrows coming out of it. So state 2 has an A arrow and a B arrow. State 3 has an A arrow and a B arrow. And state 4 has an A arrow and a B arrow. So now let's kind of check our logic here for anything else we might have missed. Something that I've been saying a few times throughout this video is that if we have nothing, then we still accept. But we have not indicated that in our diagram yet. So what I'm going to do is make state 1 our initial state in accept state. So if we end up here, that means we have nothing in our string, because nothing points back to state 1, so there's no way to get back to state 1. If we end here, that means that we have an empty string as an input, and that's still valid, that's still okay. So let's test some input strings here. Let's test AB first to kind of see how it flows, because I'm pretty sure that we have it all settled here and this is the final solution, but it's always good to check your work with test cases. So our first test case is going to be AB. So let's go from state 1 to state 2 on A, and then state 2 to state 3 on B, and we go from state 3 to state 2, and then from state 2 to state 3. We end up on an except state, and this is valid for our language. We have A and then one or more B's, 0 or more times. Now let's check for the empty string. Let's check for BAB. Let's check for ABBBA, and then we'll check for ABB. And then that's going to be it. So for the empty string, we know that we just enter on our initial state and then we don't go anywhere and we accept. And that's what we want. For BAB, we first go to state 4 from state 1, and then we loop on A and B. So we end up on a non-accept state, which is what we want because we can never start with a B. Now for ABBBA, we first go from state 1 to state 2, then state 2 to state 3, and then we loop on B, and then we loop on B again, and then we go from state 3 to state 2, which is a non-accept state, so we're going to reject. And this is valid because remember, for every A, we need a B right after it, or else it's not valid. Now, finally, for ABB, we start at state 1, we go on A to state 2, and then we go on B to state 3, and then we loop on ourselves and stay in state 3. And we accept, we're on an accept state. This is valid because ABB is a valid substring of the language AB clean plus clean star. So this is good. It looks like our DFA is good. So now let's find the second language, W, where W is any string not in AB clean plus clean star. Well, since these are complements of each other, this is super simple. We just need to reverse the accept states. So states 1 and 3 are our accept states for the first language. So let's erase those. And then whatever state is not an accept state, we make it one. So now states 2 and 4 are the accept states. Now this makes sense logically because say we're still on this first DFA here, states 1 and 3 are when our string matches AB clean plus clean star. So if we're on state 2 or 4, that means that our string does not match AB clean plus clean star. So therefore, if our language is asking for the opposite, then we're going to accept the opposite states. So anyways, this is the answer to the second language. It's that simple once you find the complement. But yeah, this should be everything. If you have any questions, feel free to ask them in the comments, and I hope all of this made sense. Thank you.